leave this up for one moment, and then I'll post the link to these, and also you will get the recording in a couple of days, as promised. All right. So, chatting with the website. So right now, if you go to any website, you'll probably see like a little search button right here, right? And this is basically apache.org. I mean, the home of open source projects. And they have a search button. And if I search for something, it's basically keyword match. So you have to know what keyword you have to use to search. Let's say you're looking for upcoming events, or you're looking for a particular project. You have to know the name of the project. You cannot just go and ask, show me a project that will help me build a website. You know what I'm saying? You have to know what you're looking for. And this is, I mean, this is not to knock down on Apache. This is pretty much just, what the web search is right now. But we can do better, right? Because the technology has improved so much, we can do actually context-aware searches. And that's what we are going to talk about. So here, actually, this is a great question because somebody just asked me this in the chat. For example, I want to ask questions using natural text, right? Not just keyword, but natural text. And I actually want the answers like a natural, like a natural in English, right? So here's a question on AI Alliance website. I'm asking, how do I join the Alliance? And actually, I do get an answer, right? Not just a little link. I have to click through and figure out if this is relevant to me. It's actually an actual answer. Pretty cool, right? So we think this is exciting. And we are going to show you how you can do this for any website. And that's what the Allycat project is all about. It's an open source project, very easy to download and use. And I'm going to walk you through it today. And we love to evolve from based on your feedback. All right. By the way, so project name is called Allycat. The name and the logo, the credit should go to Dave. So, there's a little story behind it, and we will tell you sometime. But basically, the way we look at Allycat is an end-to-end open source stack to chat with your website. It has everything you need, because remember, we are bringing in a lot of technologies together. So it's not like a one technologies bundle. So we're actually bundling about 4 or 5 different technologies, but they're configured to work well together in one package. Another way to think about is like an open RAG stack for your website. And this project is open source, right? And the links are shared here, and you can start using it right away, and also give us feedback. Now, if we going a little deeper, the way I would describe Allycat is think of like you're building like a Lego, Lego structure using different pieces of Legos, and you can sort of you can change the colors, change the shape, right? But these are all components you can mix and match and build a solution you want. So the way right now, we have a fully integrated stack featuring, so we can actually crawl a website, meaning download the content from a website. We can clean up the content. Right? Web HTML has a lot of markups and trackers and scripts. We'll clean that all up. We'll create embeddings and then save to a vector database and get it ready so we can actually use an LLM to query. Pretty cool, right? And all of this is in one package. And we even made it easy you can actually Dockerize this and deploy. Again, all of this all work through. So the best way to think about this is like a building blocks that all work together, like Legos. So again, here are some of the components I'll highlight. Again, I will go through them in detail in the next few slides. So for example, for crawling a website, I'm using a utility from Data Prep Kit. You guys may have heard about me speaking about Data Prep Kit multiple times. I've been working on this project for a while, and I'm a big fan of the project. So they have a connector that actually goes and download content from a website. That's it, and I'll show you how it is. It's very simple to use. And then to clean up the downloaded data, we use Docklink, right? So Docklink is again another very popular open source project that actually can read and parse a lot of different documents. So we use that. And then kind of process the markdown files, do the chunking, embeddings, all the stuff. We use Llama Index. So Llama Index is a framework. You may have heard of this. Pretty popular, open source. It's just like a framework for building AI applications. Right? So it does a lot of groundwork for you. So you don't have to go and do like a little low-level task. You can stay at high level, and they have libraries to do that. And this you can use like LangChain, Llama Index. There are a bunch of components. You can use whichever one you want. I just chose Llama Index because I've been using them for a while, and I had pretty good luck with them. For embedding, we are using an open source embedding model. You can plug in any embedding model you like. And also for vector database, again, right, we're using Milvus right now, but you can pretty much plug in anything. Same thing LLM, right? So all of these components, as you can see, right, they fit together, but also you can replace them if you want to switch something out, right? Let's say you don't like the the yellow block, you want to replace it with the green block. No problem, you can. So we actually very mindfully designed Allycat components that work well together, but you can also mix and match and plug and play, right? So for example, right, so for crawling a website, I'm using data prep kit connector, but let's say you want to use Scrappy, that's fine, right? You can plug it in Scrappy and use it. I'm using Dockling for my cleanup, but also you can also use data prep kit itself for cleanup or any other program. Again, vector database, I'm featuring Milvus, but you can plug in any other open source one like VB8, Pinecone, any of those guys. And also, finally, LLMs, you can pretty much try them out. So here I'm using Llama as my default, but you can try other open source LLMs and see which one works for you. And I'll show you a demo and how you can do that. So here's a basic workflow. And if you look at this as a whole, kind of looks a little intimidating, but honestly, it's pretty straightforward. So first step we are going to do is what are we going to do? We are going to just download the content. We're going to crawl the website, download the content. Second, we're going to clean it up. Third, we are going to process them into chunks and embeddings and all that. And then finally, we save them to a database, right? Because the data has to be in a database so we can query it efficiently. And this is basically a one-time thing. Unless your website gets updated, then you run it again to update the index. But basically, you're downloading the website and pushing it into a database. And after that, query part is very simple. Then you ask the query, and then the data will go to LLM, and we get an answer. And a lot of you might recognize this is very similar to using RAG on like documents. Same idea, right? Here we are using website as the source. That's it. So it's a very simple principle. We are still doing RAG, but for a website. Yeah. So, and feel free to post questions on the chat window. I will do my best to look at them and answer the questions. So you don't have to wait till the end of the presentation. Feel free to post questions. Yeah. All right. So how do you grow a website? Very simple. There's actually a, I'm also going to show you the code as well. Right. The code is so simple. All you have to do is just point to a website. And right, so like I'm actually going to use the AI Alliance website itself, right? Kind of a practicing on our own website. And all it does is just goes and pulls down the HTML pages. You can control like how many files you want to download. For example, if you're crawling a big website, let's say you're starting out, you may not want to download thousands of pages. So you can say download like 10, 20 pages, right? Just to keep it. Or you can also specify how deep to navigate, right? So websites have structures. So you can say just crawl the top level pages, or maybe like first 2 levels. So you have pretty good control on how you bring down data. So, and that's what you can see, right? So Python, we have a Python script, and all I'm doing is just point to the URL. So at this point, what do I have? So I have raw HTML data from a website downloaded sitting on my disk. Then what we had to do, right? We had to clean it up. What I usually do is like I am converting HTML into Markdown format. Let me show you an example so you see it. So here's my HTML, right? And here's a cleaned up Markdown. You see what the difference is, right? It's amazing. Because HTML, as you know, right, has a lot of formatting, a lot of trackers, a lot of scripts, right? There's a lot of stuff we don't need. What we only need is the content. And by converting into a Markdown, we remove all the excess markup, right? We clean up all the text and we extract the content. Pretty simple, right? And I'm using Dockling for this, another open source project. Yeah. So as you can imagine, these are actually right. We are doing it step by step, right? So we are step 2, we are downloading. We are converting HTML into Markdown and also cleaning it up. Yeah. Now let me look at the questions real quick. Let me see. Oh yeah. So here's the workflow. One second. Any other questions real quick? Sorry. Oh yeah, there you go. Okay, here's my chat. Right. Question is like, so basically, you will rerun this process when your website gets updated, right? Yeah. So that'll refresh the index. Yeah, that's a good question. So, excuse me, is Python the best tag for RAG? Is anything for JavaScript? Okay, so as you know, machine learning, especially AI, Python is the is the language right now. A lot of us are using it. I'm a big fan of Python, so to me it worked out really great. But there are libraries for JavaScript as well. I don't know them. I haven't used them firsthand, but if you search for them, you should be able to get them, right? But if you're going to be doing a lot of AI programming, Python is a language well worth learning. It's a really good return on investment. So I would highly encourage you to if you're, let's say you're a JavaScript programmer, maybe just know a little Python, right? Because these days you can actually write Python code very easily with like a lot of AI IDE, right? Like you heard about AI assisted programming or vibe coding, right? So even if you don't know Python per se, you can just create Python code very easily. So if you're a programmer, you should be right at home. Yeah. So Python, highly recommend it. So, actually, we'll do another session about vibe coding soon. So, and let me see. Oh, cool. Yeah. So, why not browser extension? So, question was like, can we just do like a browser extension to do this? Possibly. However, once your website, remember when you're doing the browser extension, I think again, I think it only has access to the current page. Maybe we have, we are downloading the entire site and then process it, right? So let's say you're like thousands of pages, probably it's easier to do it as a backend process than on a browser. Right? So that's how we look at it. Yeah, very good. Okay. So again, we talked about docling, right? Docling pretty much can process any document format, and it can clean up, it can extract content, all that good stuff. Yeah. All right, so I have the data downloaded. I cleaned up the data, so I have some nice markdowns. What are the next steps? Chunking. Again, you recognize this as part of a RAG process. So chunking is basically splitting a document into pieces. Why we do this is because it allows us to search very quickly and efficiently. So imagine I have like a huge HTML, let's say 20 pages of HTML. I convert to Markdown, so let's say the 20 pages become 10 pages, but still that's 10 pages of data I want to search through. But if I split them into chunks, then we have manageable, like paragraphs, sections we can search through. Because if you look at 10-page document, your answers are not going to be in all 10 pages, right? It's going to be like maybe like one page, even like one paragraph. So I want my search to basically zero in on those paragraphs, and chunking helps us to do that. Right? So splitting them into smaller chunks. Yeah. Again, and then finally, once you have chunks, we want to create embeddings. Why embeddings? Because embeddings are basically what allows us to do text search very quickly and also with context. Yeah. And once you have all that, then data goes into a database. Now, very quickly, embeddings are just, if you're not new to embeddings, what we are doing in embeddings is we are converting text data into just a bunch of numbers called vectors or embeddings. This may seem like random numbers, but they're not random. They are calculated. And what they do is they allow us to actually do search very quickly. And this is what the vector databases do, right? When you store data, they actually store the embeddings, and they actually search the embeddings to give you very fast results. Now, this is done using models called embedding models. I am using an IBM model. Again, remember, it's just an open source model. You can pretty much plug in any model you like. We're not tied to IBM in any way. Just this happens to be a pretty good model. It's pretty small. You can see it has 30 million parameters, right? You can see 30 million. And it's very efficient, actually. It's producing really good results. So I used it. I liked it. So I'm sticking with that. But there are so many other embedding models available. If you go to Hugging Face, you can download and use anything you guys like. And you can experiment, right? And like I said, everything here is pluggable. Like, for example, let me show you the code real quick. So how do we do embeddings? Like, for example, in Allycat, bring my code real quick. So here, there you go. Right, here's my embedding model. You can see hopefully my code, right? And you can see I've tried a few embedding models. It's a little larger. There you go. Right. So I tried, sentence transformers, mini LM, BGE, and IBM using IBM right now. So you can very easily plug in any embedding you want. Just takes one line of code change, and then we will download the model and run it. It's very convenient. So like I said, everything here is configurable and modular. All right. So, and finally, we save to vector database. Which vector database? Right now I'm using Milvus as an example, but I also done this with VB8, another open source database. But you can pretty much plug in any open source database, or even non-open source, right? As long as you know how to write to it, you can just write to it. Yeah. So here we want to keep the stack as open source because the AI Alliance, we believe in open source AI. So every component I'm showing you here is open source. So, all right. So finally, my data is in, right? After we've done all this work, now my data is in the database. All right, so time to query. So here, you can just run a query. We can run a command line query, just supply a query. So what happens when I do a query? We go to database and ask for documents. So now imagine something like I'm indexing AI Alliance project. So I'm asking query. Okay, what are some of the projects AI Alliance doing? So go to the database. Now imagine I have say 100 documents in the database. Out of the 100, maybe 2 or 3 documents will have answer to this query. So the vector database will look at the query and only give the pages that has the answer. I should say chunks, right? Technically, the chunks are what we are storing. So whatever chunks that have the answer, we'll give those. And those chunks are sent to the LLM. Now LLM will read through them. And then remember, language model can understand the text. So we read through the text, look at my question, and then give me an answer. Right? So sometimes people ask me, why don't you just query vector database? So vector database, remember, it doesn't give you the answer. It gives you the context. Context means what are the relevant documents that may have the answer to the question. Just like Google search. Remember, when you do Google search, what happens, right? They give you a bunch of links. They don't give you the answer. I mean, now they do, right? Now they use the AI to actually give you the actual answer. Like, for example, if you do a Google search of, let's say 2 years ago, if you do a Google search of, how do I bake a potato, right? They're going to give you a bunch of recipe links. Then you click on each recipe link, and then you have to go read through them and say, oh, okay, if to bake a potato, I need to set the oven to like whatever 400 degrees and bake it for 15 minutes or something like this, right? Here, so you have to go to each link to find the answer. But now we are going even one level higher, right? We don't even you need to have to go through each link. We'll give you the answer right away. So the vector database is giving you what sort of Google is doing. It's giving you the relevant links. The LLM is reading through them and actually giving you the answer. So now if you go to Google and ask a question like, how do I bake a potato? Right on the top, right? They will give you like an AI answer. They will say something like, heat the oven for 400 degrees and, put your potatoes in and bake for 15 minutes or something, right? So you don't have to go to the link anymore. Yeah. So anyway, so that's exactly what we're doing. So, when we are, let me actually do a quick break and take a look at the questions. Question is like, is it designed for external website? It could be external or internal, right? For example, let's say you have an internal company website and you want to index, you can use this. Pretty much, any website you can access. This you can use. Yeah, that's a good, because a lot of the time, let's say you may have internal website with like sensitive documents, right? You don't want to expose to outside world. Yeah, you can remember this Allycat runs. As long as you can access the documents from your internal network, you can use Allycat. Yeah, that's a great question. What do I look for in embedding model? That's a great question. We talked about embedding model. So basically performance, right? If you look at embedding models, let me do this real quick. All right. So there's actually a leaderboard. There you go. Here. So this leaderboard is basically they run these embedding models through a bunch of benchmarks and give you a score you can look at. There you go, right? So right, you can you can go through like regional if you want like multilingual, English only, right? And then basically it's a compromise between the larger how good you want the performance to be. And remember, some of these good models, they're going to be very expensive to run, right? They're big models, they take a lot of resources. And remember in the mini LLM right here, it's kind of it doesn't really give good performance like 40, right? Like 40 percentile kind of a thing. But it's pretty small, you can see. And as you can see, right, the larger and larger model, right, you can see the number of parameters, right? It's like 10 million parameters. Now we are like, what is it, like approaching 100 billion parameters. As you can imagine, they're very large models, but they give you pretty good performance, right? You can sort of see here, right? We are approaching 70–80% in the score. So yeah, so it's kind of a trade-off between performance and size, right? How much resources you want to spend running the model. So it's a trade-off. So and honestly, to me, the IBM model I just showed you actually did pretty well. It's a pretty small model, but produces good answers. So yeah, so there are benchmarks you can look at, but the final benchmark that matters is how well it works on your own data. Right? Yeah. So very good question. All right, let me. Oh yeah, so how do we detect hallucination? That's a great question. Let me talk about this a little bit. That's a great question. So when you ask an answer, right? So you're asking an answer, so asking a question, getting an answer, how do you know it's correct? So, because and this is actually a very loaded question. People actually spending time researching. There are even startups just focusing on this single question, like how do we know the answer LLM is giving you is the right one? There are a lot of tools available. You can some of them are open source, some of them are proprietary. You can plug them in. So what they will do is like they will kind of sit between you and the LLM, like a mediator, and they will give you a score. So you ask a question, LLM is giving you an answer. They will attach like a confidence score. They're like, oh, this answer is we're giving like A+, meaning like it's a pretty good answer. Or then some of the questions they say, oh, we're going to give it like B. So then you can go back and say, why is LLM giving me an answer that's B, right? How can we improve it? So it's like a repetitive process. It's a little too much to go into right now, but if you do a search for hallucination detectors or LLM monitors, there are a bunch of these tools you can get and use. But basically, they can, right? They're like give like a score for the answer. Yeah, that's a great question. So you want to do that. So anything serious you want to implement, you want to have some sort of a scoring system. So even right? Like because if you don't measure, you don't know. That's what I always say. So I always say, let's put in some basic scoring mechanism. So you can say something like, okay, my LLM is doing like 85% on average. That's good, right? If your LLM is doing only like 40% average, maybe right time to go back and see what's going on. Yeah, great questions. All right, guys. Let me. How do you run the LLM? So you can run LLM locally or using like in the cloud. So if you're running in the cloud, right, as you can imagine, just need to sign up and get an API key, and then very easy to get started, right? And you can do right? You can do a lot of models. You can pretty much say, okay, I want to run DeepSeek, I want to run Llama, I want to run Gemma, whatever. And you can run large models because a lot of these online cloud vendors, they have GPUs built in. So you don't have to worry about what infrastructure you're running on. Just say, run this model for me. That's it. And of course, you pay for use. There are so many of these companies like Replicate. I use Replicate. I really like them. AWS, Deep Infra, pretty much every cloud platform you can imagine, right? Amazon, Google, they will allow you to do this. Now, running it locally, so I would say 80–90% of the people who run this on the cloud because it's so convenient, right? Just get an API key and then just you're on to business. But sometimes you want to run locally. Why? I had a couple of clients who basically said, our data is sensitive. Please do not send the data to ChatGPT or any cloud platform. So for the project, I actually ran an LLM locally, and then Kansas. So There are a lot of open source LLM that are really high quality ones. You can actually run locally. I'll show you how to do them. But again, remember, it's a bit of an involved setup, right? So now you have to be able to run LLM locally, and you may need to have some resources. Like for example, you need to have a good GPU to run higher models. Yeah. But security, meaning like your data stays here, right? You're not sending data to some cloud. Right? So, and also your cost is pretty much fixed, right? Like once you buy the hardware, the models are open source, right? So you can run them. Once you have the hardware, then it's just a matter of expense of running the hardware and electricity and maintenance and all that. Yeah. And Ollama is the one I use. Very good. I'll show you. Okay. So here's how easy it is to run. So this is a replicate. I'm going to replicate here. Again, you can use it in any of the other one. I'm not trying to replicate in any way. I'm saying replicate here, run this for me, and run this model. That's it. I don't have to worry about anything else. I don't care about how they approach the machine. I don't care how they run on GPUs. Right? Just models. Yeah. So this is what I recommend if you're getting started. Go with this if you can. Right. So if you're running locally, so there are a bunch of various options, but Ollama is probably the best and easiest. Here's how to run it. You basically install Ollama. You download the model. So let's say I'm going to run Gemma 3. This is from Google, right? I'm going to download the Gemma 3 1 billion model. No. That's it. Easy. Yeah. So. All right, so we run through all this. So let's see how it works, right? Actually, I can actually show you this code. I'm going to see how they do time. Okay, very good. So here's the question. I'm asking the question: what are the main focus areas of AI Alliance? And answer. What are some of the Alliance projects? Answers, right? And I'm going to do a demo, so I'm going to spend a lot of time on this one. I'll show a demo real quick. But another thing I always ask, and this is part of the hallucination. Somebody just asked me. This is kind of my way of manually testing if the model is hallucinating. I always ask, when is the moon landing? Now we know this is public knowledge, right? All the LLM, will know the answer, but the LLM should come back and say, I cannot provide the answer because the context or your documents don't have the answer. You shouldn't be freelancing and say, oh, moon landing was whatever, right, 1968 or 69 or whatever, right? And this is something I always ask, and this is kind of a bit of a manual check to say, is my model hallucinating or freelancing? And here it's come back and say, yeah, no, I know, I can't find the answer in your context, which is what we want. So, right. So, all right, let's do a demo. What I'm going to do, I'm going to run from a local environment. I'm going to show you how the project looks. And you can also run using your Python environment, or you can run out Docker. Either way, so I'll show you both. Okay. So let me actually do a demo here. All right. So if you look at our Allycat project, right? So here's our Allycat. Let me put this link one more time. And go to the project. You will notice my files are marked 1, 2, 3. Those are the steps. Yeah. And let me show you how easy it is to run. So I already have my environment set up. Right. I'm going to run this real quick. Let me get the AI Alliance website. So what I'm going to do, again, I'm just going to follow the README file very simply. Right. So I'm going to call a website. Python call website.py. Right. So that's step 1, and I'm going to give the URL. My URL is, let's just look at AI Alliance website, right? So the website I'm looking at is this. So let's see how it does. So hopefully it works. Yeah. So as you can see, it's downloading a bunch of files. So I'm actually printing out what files I'm downloading, so we can kind of see, right, what we are getting at. And then it's right. And it's going to download maybe about probably close to 100 files, I think. Last I downloaded. There you go. Web crawl completed, 98 files. Yeah. And if you look at the input directly, right, see a bunch of HTML files downloaded. Very good, right? So at this point, I downloaded the file, and this could be in the thousands. You can limit the number of files you want to download. So for example, if you just say Python, if you just do it by itself, they'll give you the option saying, hey, you can give me the URL. You can optionally also give me how many files to download max, and also how deep you want me to traverse the website. Right? Very easy. All right, so I have the file downloaded. Next step, again, I'm putting the README file. I'm going to process the HTML file. I have two choices here. I can use docling, right? Or I can use data prep kit. So I tried both, pretty similar results. So let me actually show you the code. So I'm going to say Python. I want to say, let me just process 2A, right? Just using docling to process. Yeah. So all this is doing is like it's basically converting my HTMLs into Markdown. Remember the diagram here? Yeah. Right. So we are step 2. Yeah. Then next steps, we are going to basically save, or we are going to combine all the steps and save to a database. Okay, so 9 HTML files converted. There we go. And the next step is step number 3. From 1 to 3. Very simple, right? They want to save our database. So save our data, split in the chunks, everything, and save to database. And in this case, I'm using Milvus. That's it. By the way, you can see, right? It says created 235 chunks from 96 documents. Yeah. And you can see it's saved to Milvus, right? Yeah. So this is like a little exception I'm getting from Milvus. Don't worry about them. It's harmless. It's like we are fine. So it's storing 235 chunks into Milvus. So for example, my database now has all the chunks indexed and ready to go. All right. So now let's do the query. So Python, step 4 is query. So right now I'm using replicate as my engine, right? You can see, right? I'm using replicate as my engine, and let's just go with it. So I'm running my model in replicate. So what does it look like? So I have a few queries I'm going to ask, right? And just so you can quickly look at the answers. So I'm not going to type them in, right? So it's initializing everything. It's going to come back, right? There you go. So these are some of the answers, some predefined questions I had. Let me walk you through them, right? So first question, what is AI Alliance? So remember, this is just a question I'm asking. So I just pre-programmed them in, so I don't have to kind of type them in during the demo. And the response is, right? So AI Alliance is the international community of yeah, that's very good. Oh, there you go. All right. Next question. What are the main focus areas of AI Alliance? Response. Right. There's no provider context, right? You can see, right? Alliance, right? 6 focus areas, right? Yeah. So, what are some AI Alliance projects? Okay. Comes back and say, core projects, affiliated projects, right? So as you can see, now actually, I'm asking natural text questions, right? And I'm getting natural answers, not just some links, right? So this is how nice it is. You can actually ask questions, pretty much, in natural language, and give you the answer. What are the upcoming events? Again, remember, this is the question I'm typing in, right? I'm not like searching for it, right? And clicking on anything and say, yeah, here are the answers, right? And you can see, right, the dates. You can look at the dates: May 1, May 6, right? So it skips the previous events, which is nice. Remember, I asked what are the upcoming events, so it's giving me the answers. Very cool, right? So as you can imagine, this is very, very powerful feature. I'm just showing you like what's possible. You can imagine this, these queries can be pretty complex, right? And models can handle it. How do you join AI Alliance? There you go, right? So you can say apply on like 1, 2, 3. Apply online, right? These are all the options. And here's my favorite question: was the moon landing, right? It says, yeah, I'm happy to help, but I don't see any information about moon landing in your context. And this is what you should see, right? You don't want like models kind of guessing the answers. All right. So let's say, and here, this is some of the predefined question I asked. So let's say we will ask, let's say, I don't know, how many organizations, how many members, who are the members of the alliance? Yeah. All right. There you go. All right. So just give you like a few members, right? Pretty good. So as you can imagine, so this is the text version, by the way. I also have a UI A very simple UI, right? So you can actually just deploy it online. And let me show you. So we actually have a very simple Flask-based UI. I'm running it here. I just started it, so you can see, right? So I'm just another, Flask, the simple web framework in Python. So I ran this, and you can see it's initializing, right? There's my UI. There you go. So very simple UI, right? Chat with the website, right? And you can actually embed this in your website. So for example, let's say, right, you can, let me ask, how do I join the AI Alliance, right? So there you go, right? Yeah. How many members are in the AI Alliance? Yeah. So they say over 50 founding members. Yeah. Pretty good, right? So very simple UI. Again, we kept it very simple. Again, it's just a simple chat interface, right? You can simply embed this on your website, right? So somebody could ask questions. And let's do one more. What events are happening in San Francisco? Yeah. All right. Let me see. Actually, yeah, I do know these are true. Okay. So all of these, and you can see these are all future events, right? May 1, May 6th, right? And they are happening in San Francisco. Pretty cool. So as you can see, right, we have a full stack for you that can do all of this. So just to kind of revisit, start with the crawling website, cleaning up, indexing, saving the vector database, and then finally queries. You can run the queries on a command line, right? So I've done it just so I can test it very quick. And also we have like a very simple app in UI. Yeah, pretty cool. So how do we deploy this? So this is I'm running this on my machine. Actually, I want to show you something real quick, right? Let me fix it. I'm going to show you how to run the LLM locally. Now, I just added this yesterday, so I'm pretty excited to try this out. So what I have to do is I'm going to use Ollama to run the model. And these are some of the models you can see. I can experiment. And I look at the model sizes. So you're like, go and actually, by the way, this is a very nice model that just dropped a week ago. Gwen 3 models. It's getting a lot of good reviews. So I can run Gemma is from Google, Gemma 3 is from Google, Llama 3, which now is from Facebook. Right? These are all the open source models. You can look at them here, right? Ollama models. If you go to Ollama, you will see all the models they support. And by the way, these are all open source models. You can download them and run them. All right. So I want to actually run this. Right? I don't want to use replicate. I want to run everything locally. So all I have to do is just change one line of code saying LLM runtime environment, Ollama. All right, let me show you here. I want to start the query part. Right? So remember, this is running locally on my machine. Hopefully this works. Right. Okay, so I'm using Ollama, right? All right, so it's running already. So I'm using Ollama, right? Using Llama 3, a 1 billion model. Yeah. So what is the alliance? There you go. Pretty cool, right? What are the main areas of focus alliance? Pretty cool. Running locally on my machine. Let me show you one model. That's pretty cool. It's a thinking model. It's pretty nice. Let me switch the model. Let's say I want to try something else. All right. Let me try when. So this is something I just downloaded yesterday, and you can see it's a very tiny model, only like 500 megabytes. 500 megabytes is a tiny model because you can see the other sizes, they are in gigabytes. All right, let me run this again. So this time it's going to be running in Qwen. What I want to show you is actually it's a thinking model. It's a reasoning model. I want to show you how it's thinking. So okay, it's using Qwen. Right. This is the smallest model, by the way. There we go. All right. So let me show you one. So what is the AI Alliance? This is my question. In the response, anything between think, this is how the model is actually evaluating my question, right? So you can start sitting and say, okay, the user is asking what are the airlines, and they provided context, right? So remember, this is the basically a way into what the model, how the model is finding the answer. I actually like this because this kind of gives you a little insight into how the model is, working, right? So first in the about airline section, so they're saying, okay, I'm looking at the section now, right? And they're saying, this one has information. Then, looking at FAQ section, right? I'm looking at the member section, right? And then because user code is straightforward, right? And I'm going to give like a very concise answer. And then, so this is basically thinking basically meaning, what the model is, how the model is working. And then it says, yeah, like this is the actual answer. Pretty neat, right? So I actually like this, the thinking model or reasoning models, because you actually get to see them, how they work. All right, let's do one more. What are the main focus areas of AI Alliance, right? Thinking, okay, right? So it's saying, right? So it's kind of context and mention focus areas, right? And then right, it's looking at the section. This is actually like looking at outline, and then it comes and right? Yeah, pretty cool. Yeah. Let me look at there's the moon landing. There you go. When is the moon landing, right? So things and say, okay, yeah, let me check the provider context, right? And then it says, you know what, right? So it says, yeah, I can't find anything on here. So let me just tell the user I can find the answer. Pretty neat, right? So running local models, like and open source models, you can see, they are. I mean, even this is a very tiny model. You can see, right? It's fine to make, right? Smallest of all, but it's doing really, really good. So you don't. What I'm saying is, you don't need to run gigantic models to to do this, because now the open source models have gotten so good, right? You can see, you can even see how they operate. You can see the answers. So you can just bundle them and deploy them with a smaller model. You don't need like huge GPUs or whatever to deploy. All right, very quickly, and we're coming up on time. I'm going to show you this. All right, so this is good. We develop this. How do we deploy? Right? Because right now it's running on my machine. How do I deploy this? So let me show you real quick. Everyone. So everything's Dockerized. So once you build, so the way I do this, I run the crawling, cleaning, and indexing everything, right? Right, and then we build a Docker container. So when I do this, I am actually building my data in the database. From my data is being indexed and my database is being built with all the new content. Then we Dockerize it. So the Docker container actually has the executable code, all the libraries it needs, and also all the data it needs in the vector database. Yeah, and then we can deploy, a Docker to basically any runtime. Here's how right. Just a couple of quick words on the best practices. So, like I said, I like everything to be self-contained. By the way, this Docker is available publicly. You can even just just download the Docker and just run it from Docker. You don't even need to install Python. That's how easy it is, right? And another thing I noticed when I was Dockerizing this component, when I'm Dockerizing the PyTorch, the default version. Oh, sorry, this should be flipped. This should be. Oops, I'm not going to that. This is GPU. This is CPU. There we go. Yeah. So the GPU version by default, PyTorch installed the GPU libraries, and it can really add to your data size. You can see, right? It's 10 gig container size. Then I said, no, because don't install GPU libraries, because I'm not going to be running on GPUs anyway. I'm just running on plain old CPUs. So there's no need for me to bundle all the libraries that I never use. So what we do is we actually create a CPU version. You can see it's much smaller size. So we actually implemented all these best practices here. So when you Dockerize it, you get the minimal possible size. So here's how I deploy to Google Cloud. Literally 4 steps, right? So I'm building my Docker, right? So it actually bundles everything, right? Code, data, libraries, everything into a Docker container. I'm tracking this Docker container to my project. So this is what ties my container to a Google project, and I'm calling it Allycat. Right? I'm pushing it to Google Container Registry, GCR, Google Container Registry, yeah, GCR, right? And then from there, I'm running deploy. That's it, right? So when I do deploy, you can see, right? I am not specifying how many instances to run and everything. I just deploy this. Google will take care of everything behind the scene. So they will automatically deploy this in a runtime environment. And if it's getting a lot of traffic, they will automatically scale. And when the traffic diminishes, they will automatically start decommissioning. Pretty cool, right? So this is what you want. You want to like have your application as a container. Then you can all this cool stuff you can do. So you're not manually managing infrastructure. That's Google's job, right? So if your app is getting a lot of traffic, they will scale automatically. So all of this. So again, I'm deploying in Central, right? And all I did was I said, right? You can even do things like only run maximum of 10 instances if you want to be mindful of cost or whatever. Otherwise, just let them have it. Yeah. So that's how easy it is. We made this too long. No. All right. Finally, how can you contribute? And so just use it, right? Please download it and use it. Try it on your website, see how it works, and give us feedback. You can come back and say, hey, I am running into this issue, and we'll help you address that. We will, if it's something we need to fix, we will fix it. Even better, you can submit PR. I love those. And if I can ask you a favor, maybe right now, we can go to the website Allycat and give us a little star. We'll really appreciate it, right? Because we actually launching this project. We want to make sure right we get enough traction. So yeah, so you can open issues, you can ask questions on the discussion forum, but please do give us stars if you can. We really appreciate this. All right, guys, that's it. So yes, a couple of minutes over. Final slide. Thank you so much. This is the link. Let me put the link also one more time for the presentation and the code. So you can go right there. Thank you. So yeah, so if you're on GitHub, like I said, give us a star at least. it's like I feel like I'm asking for Yelp reviews, but we are done. So thank you so much. Hopefully you found this interesting and useful. We cannot wait for you guys to kind of try this out and give us feedback because we want to grow this. Right, this is not like a done project. We are just starting. I would say that we are like at version 0.1, usable, deployable, and useful. But we like to evolve the project based on your needs and feedback. Thank you, guys. So let me do this. You feel free to drop off, but if you have any questions, please hang around. I'm happy to answer your questions. Let's see. Let me look at the questions here. Put that on your chat.
By the way, I just want to comment. By the way,
yeah.
Where was it? Yeah, Puzzle Deck says he's scraping his site now.
See, this is what we want to see. Yeah,
exactly.
Yeah, exactly.
That's how easy it is, folks. Within a matter of a short talk, you can be up and running and scraping sites.
Because honestly, right? Dave will agree with me on this one. There are a lot of open source projects, right? I also can say, right, if you want this to be useful to you, something you can use, you can adapt, you can deploy internally, externally, right? So please use it. All right, a couple of questions here. Let me go through. What if a website is constantly updating? That's a great question. So let's say you have a dynamic website that's kind of being updated. So then what you want to do, and this is actually a great question. We are thinking about this. Let me go back. There you go. I'll just show here, right? So this pipeline you want to run, but you may not want to download to the whole indexing again. So what you want to do, you want to be a little smart. When you do the crawl side, you only want to download the modified ones, right? There should be some logic here, in your crawler. You can specify only download documents that are modified after, right, your last snapshot. So instead of let's say your website has 1,000 pages, 10 pages updated since yesterday. So now you are updating only 10 pages. Now go through the same process. When you save to a database, right, you're basically updating the existing index. So you have 1,000 pages initially. Now you're like, let's say 2010. Yeah. So yeah. So this process you want to be a little smart, and you can run this on like some continuous loop, right? It's like something like like maybe you want to update this like every 10 minutes, every hour, once a day, whatever, right? The frequency is up to you guys, but yeah, you want to run this. But once the data is in the database, then users will see the new data immediately. Yeah. So yeah. So you want to refresh this pipeline as often as you like. Yeah, that's a great question. So you're going to be, we are going to be doing little smarter things like only doing incremental update and things like this. We may actually implement them based on requests. So yeah, please give us some feedback. Open requests. We will definitely evaluate them. That's a great question. Yeah. Yeah. So you can run this processing side on a cron, like in some of the automatic thing, right? Let's say your website is updating frequently. So run this like every hour, every 10 minutes. Yeah. You can automate this whole step. So every script I showed you is you can just put in a cron job and run it. Excellent. Yeah. All right. Right. I love this. All right. Session is recorded. You will get an email in a couple of days, and they will all end up in YouTube. Yeah, you can always get them. Yeah. So again, if you have any other frameworks that you are using, I'm sure there are a lot of frameworks in like to do like crawling and indexing and all this. Do let us know, right? Do let us know like some of the features you like or you want to see it implemented. But the idea here is we want this to be extremely simple to use. But extremely simple doesn't mean just a demo version, right? We actually want this to be usable, and you can see right now, right? I actually have it in such a way you can actually just do this and deploy to any cloud you like very quickly. So, oh yeah, somebody said UI. Yeah, so the UI is very basic. By the way, I have to tell you this. I am not a UI person at all. So I actually used the AI to generate this UI. So I said, hey, I have a website. Can you create me a simple HTML JavaScript-based UI to use this? And it did. And it did a pretty good job actually. So I used like a cursor IDE to say, hey, here's my Python application. Please create a simple UI for me. So yeah, so the UI is as simple as it can be, from just a text box and text, right? So yeah, so I'm sure you can do a much better job than this. But yeah, but this is something we want to demo and showcase and say, hey, you know what? You don't have to just type a command line. You have like a simple chat interface. Yeah. So yeah, so this is actually AI, right? So because I don't know a single line of JavaScript. This is all generated by AI. Yeah. So, Streamlit is pretty good. Yeah, somebody said Streamlit for UI. Actually, very good. I used Streamlit before. It's very good. I actually started using Streamlit just so you mentioned it. So Streamlit has a little issues with especially when you're loading models in the background. There's some issue with threading, so you have to be kind of careful when you mix and match Streamlit with database query threads and things like this. Sometimes you may get into trouble. But yeah, nothing solvable. But yeah, just be mindful when using Streamlit. They use threading pretty heavily, and you may want to run into some threading issues. Yeah, just watch for that. Flask, here we are running on a single thread application, very simple, right? Everything happens in a single thread. Yeah. So very good. Good, guys. So I'll stop here. I don't want to take too much of your time. Thank you. Again, remember, you can just come to the website, right? Ask us questions anytime. So 6. Okay. Yeah. So right, discussion forum is where you want to be, and yeah, ask us questions, open issues. Cool. I see stars already going up. Nice. So that's very good. Dave, anything else? I think we are done. We don't want to take too much time.
Yeah, I think we're done. Do have a hand up though. Let's see if we just get a quick hand from Raman.
Yeah,
Raw. Say something.
Yes, go ahead, please. Yeah. And others, you're free to hang around or please feel to drop. Yeah. Thank you for coming. Yeah. So go ahead, Raw. Yeah. What's your question?
Oh, he asked the question: is it possible to use for e-commerce business? Oh, I'm sure you can. Hey, by the way, if anybody wants to use this in their project, please let us know how we can help you.
Yeah.
This is meant to be a simple project. but it is also meant to be used in production, meaning that if there's things that you need to do to make it work in production, we would like to help you. We may not take all of those contributions and put them into the project, but but something like a WordPress, like if there was something that needed to be done specifically to make it work for WordPress, or that would make it easier to work for WordPress, I mean, that'd be a great one to add to Allycat. Yeah.
Because there are so many WordPress blogs and websites out there. So definitely let us know, please. Right. So like I said, this is if I were to give it a version, this is like 0.1, right? But we want to keep working on this. But we want to keep working on this in a way that's useful to you, right? Not just add some random features, some useful features. So please, let us know. All right. How do I get in touch with you guys? So simple. The best option is come to the discussion forum here, right? And you can ask questions, open issues. GitHub is the main way to get. Let me put this link here. So you go to the main website, look at the discussion tab. It's like old style forums, right? You can ask questions, get answers. Very straightforward to use.
And PuzzleDeck has a good question about the licensing. I think one of the reasons why we like the Granite one, in addition to the fact that it's IBM one, of course, you got to try out your own company's model. But also the licensing is extremely liberal. It was created and meant to be essentially open source in all ways that it can be. So that, for example, all the data, IBM knows where all the data came from. It's all licensed appropriately, and it can be freely used. So that is one good reason for using Granite models.
That's true. Right. Very good point. And every single thing in the stack is open source, right? Because like I said, we are very big on open source. We want to make sure there are no liabilities, right? No restrictions. So everything here.
I think PuzzleDeck does have a comment though. I mean, you do have to take a look at the model you're using, because I think maybe he's pointing out the fact that you may have referenced some other models in your code in different places, and all of the models might have a slightly different licensing, even though they call themselves open source. That might not be completely open source. So you should take a look at it and just make sure that your use case does not violate its terms.
Exactly. Like for example, Ollama, I'm supporting all this, right? For example, some of them could be free to use, but not really open source, right? So you absolutely want to check and make sure.
The IBM Granite one is definitely free. The whole purpose of it, it's open source and free to use. Some of the others, like Llama, have some restrictions if you're going to use it for like 100 million users or something like that. I forget what the number is, but you might have to register your use of it. So it's not purely open source.
But the good news is there are, this is true now than 2 years ago. Now we have very good high quality open source models that are very close to the proprietary models, right? Some are like, for example, that's what like people are saying, like Gwen 3, it's even challenging. Like the highest model, like the 235 billion model, it's very close to ChatGPT, right? So now we are at a period at a time, open source is really catching up, and sometimes even doing better than closed source models. So which is really great. So good, guys. Let's wrap this up. Dave, anything else? I think we covered everything. So.
No, I think so. I mean, thanks again, everyone, for participating in the call, and I hope you enjoy it. I know I enjoyed the session. Every time I watch Sujee give a talk about it, I learn something new. But I would love to get your collaboration with us on this project. So please take a look at the GitHub repo, try out the project. If there's something that you want us to add to it, you can open up a discussion, or if there's something very specific you already know about, you can issue an issue, or you can, if you make some changes to the code, you can submit a pull request.
Yes, we like those too. All right, guys. Thank you so much. See you in the next one.
All right. See y'all.